Good morning. In the last lecture, we discussed negations of compound statements, important rules. The first one, what is negation of conjunction? It is nothing but disjunction of negations. What is negation of disjunction? It is conjunction of negations. What is negation of implication? P implies Q. This is P and not Q. This is very important. Number 4, negation of biconditional. It is P and not Q, or not P and Q. And the simplest one, negation of negation, is nothing but original statement. Now exercise 1.3, as I said, third question, write the negations of the following 4 statement. It is cold and raining. Let P be the statement, it is cold. Actually, I should have written, therefore not P, it is not cold. Let Q be the statement, it is raining. So not Q, it is not raining. Now the given statement is P and Q. So what is its negation? Not P and Q is not P or not Q. So it is not cold, or it is not raining, or just say or not raining. Now what is the fifth one? If it is raining, then we will go and play football. So 2 statements will be, let P be the statement. In fact, we have 3 statements rather. So I have to say it is raining. Just check this. It is raining. Q, we will go. We will go. And R, we play football. So what is the given statement? Symbolic form, I mean. Just read the statement again. If it is raining, so P then means implies, you have to use bracket, Q and R. So this is interesting. This is given statement, right now. And what is negation of implication? So this is P and negation of Q and R. What is this? Okay. That is P and. Now it is negation of Q and R. It is negation Q or negation R. So you have to put this in words. That is, it is raining. It is raining and we will not go or not play football. And we won't go. We won't go or not play football. Yes, right down. Sum number 6, rather statement number 6. Root 2 is a rational number, simple statement. So its negation is obtained by using the word not at proper place. So what will be the negation? Root 2 is not a rational number. Now next three are important. Seventh, all natural numbers are whole numbers. So clearly you have to use the word not at proper place. Not only that, all will change to some, SOME sum. So what is the negation of the given statement? Some natural numbers are not whole numbers. Now sum number 8. For all n belonging to set of natural numbers, n square plus n plus 2 is divisible by 4. So what will be the negation? Negation is, now for all, that is universal, will change to existential. So there exists at least one natural number belonging to n such that n square plus n plus 2 is not divisible by 4. Ninth one, given statement is there exists at least one x belonging to n such that x minus 17 less than 20. Negation is, for all x belonging to n, x minus 17 is not less than 20, or you may say x minus 17 greater than or equal to 20. Now the next sum is on converse, inverse and contrapositive. We have already discussed this. See, for implication, P implies Q. What is converse? Q implies P is converse. Not P implies not Q is inverse. And not Q implies not P is called as contrapositive. We have already written that the given implication and its contrapositive are logically equivalent. So fourth question, write converse, inverse and contrapositive of the following statements. First one, listen to me. If x less than y, then x square less than y square. X and y are both real numbers. Let P denote x less than y, Q denote x square less than y square. See, this is how you have to present. Then the symbolic form of the given statement is P implies Q. Converse, Q implies P is the converse. So it will be, if x square less than y square, then x less than y. What is the inverse? Not P implies not Q. So if x greater than or equal to y, or you may say x not less than y, same thing. If x greater than or equal to y, then x square greater than or equal to y square. See, or if x not less than y, then x square not less than y square. Contrapositive, not Q, I'm sorry, this is wrong. This should be not Q implies not P, not P. Not Q implies not P is the contrapositive of P implies Q. That is, if x square greater than or equal to y square, then x greater than or equal to y. Or If x square not less than y square, then x not less than y. Okay. So this is the first one. Now what is the second statement? We'll be doing all four. Second, a family becomes literate if the woman in it is literate. So true. Right now. Second, in fact, let me tell you the statement first. Have we discussed the statement? Yes, we have. Okay. So let P be the statement. The woman in the family is literate. Q, family becomes literate. So it will be not P. The woman in family is not literate. Not Q, family does not become literate. So the given statement is P implies Q. What is its converse? Q implies P. That is, if family becomes literate, then woman in it is literate. What is inverse? Not P implies not Q. That is, if woman in family is not literate, then family doesn't become literate. Third one, contrapositive. It is not Q implies not P. That is, if family does not become literate, then woman in it is not literate. Now the next statement is, if surface area increases, third one, then pressure increases. Let P denote the statement, the surface area decreases, and Q denote the statement, the pressure increases. So it will be not P. The surface area does not decrease, not Q. The pressure does not increase. I haven't written that. So the given statement is what? Write down. P implies Q. P implies Q. Converse is Q implies P, that is. Write down. Converse is Q implies P, that is. If the pressure increases, then the surface area decreases. Then the surface area decreases. Second, inverse is not P implies not Q. Inverse is not P implies not Q. That is, if the surface area does not decrease, right? That is, if the surface area does not decrease, then the pressure does not increase. Then the pressure does not increase. Third one, contrapositive is not Q implies not P. Contrapositive is not Q implies not P. That is, if the pressure does not increase, then the surface area does not decrease. Then the surface area does not decrease. We'll do one thing. Fourth one, we will just discuss. We will not write that, or you will write the solution after the lecture. What is the statement? Let me explain. If voltage increases, then current decreases. If voltage increases, then current decreases. Okay. So we take P as what? Voltage increases. Don't write. Q, current increases. So given statement is P implies Q. What will be converse? Q implies P. That is, if current decreases, then voltage increases. Okay. What is inverse? Not P implies not Q. That is, if voltage does not increase, then current does not decrease. And finally, what is contrapositive? It is not Q implies not P. That is, if current does not decrease, then voltage does not increase. Now, these are important results. Of course, these can be proved by constructing truth tables. So the first one, we can call it as conditional law. P implies Q is equivalent to not P or Q. This is very important, especially from CET point of view. P implies Q is equivalent to not P or Q. Second, we have already discussed P biconditional Q. Why biconditional? Because P not only implies Q, but P itself is implied by Q. So this is biconditional. P implies Q and Q implies P. Then P or Q and R. This is distributive law. So I can say that disjunction distributes over conjunction. So it is P or Q and P or R. Now this is dual. Interchange the symbols for conjunction and disjunction. So conjunction distributes over disjunction. So it is P and Q or P and R. Now, if you want, you can construct this truth table to verify this. Okay. So these results are standard results. You can directly use them. Now, this part is again important. Algebra of statements. Some standard equivalent statements in logic are listed, which can be proved by using truth tables. The first one is idempotent laws. P or P is P, obviously. P and P is P. Commutative laws. P or P, or rather P or Q is same as Q or P. P and Q is same as what? Q and P. Associative laws. P or Q or R is P or Q or R. P and Q and R is P and Q and R. Distributive laws. P or Q and R is P or Q and P or R. P and Q or R is P and Q or P and R. Then this is interesting. It is called as absorption law. P or P and Q is equivalent to P. P or P and Q is equivalent to P. Similarly, P and P or Q is equivalent to P. We have already discussed Morgan's laws. Negation of disjunction is conjunction of negations. Negation of conjunction is disjunction of negations. Complement law. P or not P is true, obviously. P and not P is going to be false. So this is tautology and this is contradiction. Then involution laws. Not P is P, obviously. Negation of negation is original statement. So not true means false. Not false means true. Then identity laws. P or false is P because or means at least one of the two, right? So this is going to be false. So truth value will depend on truth value of P. If P is true, then true or false is true. If P is false, false or false is false. And that is why P or false is P. Similarly, P and false, whatever may be the truth value of P, as the second conjunct is F, result is going to be F. P or true, whatever may be the truth value of P, as second disjunct is true, it is true. Similarly, P and true is nothing but P. See, conditional law. P implies Q. As I said, that conditional is logically equivalent to its contrapositive. and is nothing but not P or Q. Now, biconditional law, we have discussed this. Why it is biconditional? Because it is conjunction of two conditionals. P implies Q and Q implies. Okay. But as per conditional law, P implies Q is what? Not pure Q. And Q implies P is equivalent to not Q or. Okay. So these are the important laws. Again, it is obvious that P and Q and R is true if and only if all are true. P and Q and R is false if at least one of P, Q, R is false. Then P or Q or R is false if and only if all are false. P or Q or R is true if at least any of P, Q, R is true. Exercise 1.4. Using rules of negation, write the negations of the following with justification. First four for homework, I have given the answers. Fifth one, we have to write negation of what? P implies P or not Q. Okay, so it's negation. See, you are supposed to write justification also. Basically, it is what? Negation of implication. So what is not P implies Q? P and not Q. So instead of Q, it is P or not Q. Yes. See, this is the justification. It is better if you write negation word completely because N is not the standard short form of that. So this is negation of implication. Start writing. Then comes negation of disjunction. So it is P and. Make use of bracket. It is not P and not Q. Reason? Negation of disjunction. And finally, P and not P and Q. What is the reason? Negation of negation. I repeat, capital N is not the standard short form. You have to write the word completely, negation. Now, what is negation of P and Q or P or not Q? See, brackets are important. Basically, it is negation of this disjunction. It is what? Conjunction of negations. Okay. Next step. This is negation of negation. So it is P and Q. And this is negation of disjunction, which is again conjunction of negations. But what is not Q? Q. You have to justify each step. So what is the final answer? Final answer is P and Q and not P and Q. Now negation of what? Basically it is negation of implication. So what is negation of S implies R? It is S and not R. Now this is negation of conjunction, which is disjunction of negations. But what is not Q? Q. So what is the final answer? P or not Q and not P or Q. Negation of not P or not Q or P and not Q. Basically, this is negation of, see the cursor, negation of disjunction. It is conjunction of negations. Now, this is negation of disjunction, which is conjunction of negations. This is negation of conjunction, which is disjunction of negations. Now it is not Q. Q. So the final answer is P and Q and not P or Q. Now this is an interesting question. Rewrite the following statements without using if then. That is, given statement is an implication, but you are supposed to drop that. The first one, or before that, let me tell you, by conditional law, what is P implies Q? It is not P or Q. How to prove this? By constructing truth tables. Simple. So, first statement, if a man is a judge, then he is honest. So, P, man is a judge. Q, he is honest. but it is equivalent to not P or Q. So a man is not a judge, or he is honest. Second, if 2 is a rational number, then root 2 is irrational. So P, 2 is a rational number. Q, root 2 is irrational number. So what is not P or Q? Do not use the word if, or do not use the phrase rather if then. So 2 is not a rational number, or root 2 is irrational number. I'm sorry. I should have written root 2 is an irrational number. Now this is correct. Third one, if f of 2 equal to 0, then f of x is divisible by x minus 2. So clearly f of 2 not equal to 0, or f of x is divisible by x minus 2. Now this is an important type rather, and not easy to prove in most of the cases. Without using truth table, prove that first one, P biconditional Q is equivalent to P and Q, or not P and not Q. Now why biconditional? Because it is P implies Q and Q implies P. Then apply conditional law. So not P or Q and not Q or P. Now distributive law, see its application is very important. So here distributive law is applied. Again, distributive law is applied in the next step. Now, can you tell me what is not P and P? False. Similarly, Q and not Q, false. You have to mention the reason. This is called as complement law. Now, this or F is simply this. So, not P and not Q. Okay. Can we write the reason for this? I think we have mentioned it as identity law. Just verify. This is an identity law. Okay. So we get what? We get not P and not Q, or P and Q. I can write P and Q first, or before that, what is Q and P? P and Q. Reason, commutative law. So there are two reasons actually. This is identity law and this is commutative law. Again, we have to write P and Q first, because these two are disjuncts. We can interchange them as commutative law is obeyed. So this is P and Q, or not P and not Q. Yes, this is nothing but right hand side. So that's it for today.